Hello everyone, I am going to explain question number 2 from chapter 2 from class 10, and this question number 2 belongs to the exercise 2.1. So the question is by Euclid's division lemma, show that the cube of any positive integer is of the form 9 cube or 9 cube plus 1 or 9 cube plus 8, where q is any integer number. So here again we have to use the Euclid's division lemma, and we have to prove that cube of any positive integer. So this time we have to prove the cube of any positive integer, and we have to bring it in the form of 9 cube or 9 cube plus 1 or 9 cube plus 8. Since here we have 9 cube, so we have to see what are the multiples of 9, means what are the numbers which divides 9. So 9 is divisible by only 3. That's why a is any positive integer and b is equal to 3. So this b equal to 3, because in question number 1 you can see in my previous video I took b equal to 4 because that time here 8 was there. So 8 is divisible by 2 as well as by 4. So for better choice I selected 4. Now here since 9 is there and 9 is only divisible by 3, so we don't have any other option. We have to take only b equal to 3. So in this a and b equal to 3, we are going to use the Euclid's division lemma, that will give us a is equal to 3m plus r. So what is m here? Quotient. R is the remainder. Now since divisor is 3, so for r the restrictions are r is greater than equal to 0 but less than 3, because divisor is 3. So if r is this, then the values of r, possible values of r is 0, 1, 2. Now in this a equal to 3m plus r, we will substitute r equal to 0, 1, 2, 1 by 1. That will give us a is equal to 3m, then a is equal to 3m plus 1, then a is equal to 3m plus 2. Now in this question, like in question number 1, they had only told to prove the square of positive odd integers, so we selected odd numbers. But here we have to prove for any positive integer, either even or odd, for both you have to prove. So whatever options we got here, we got only 3 options. For all 3 we have to prove, and what we have to prove? Cube of the number. So first I wrote a is equal to 3m, then cube we had done. So when we do the cube, power 3 will come. So multiply it, write it 3 times, that is 3m into 3m into 3m, that will give you 27m cube. Now since in the question we have to bring in the form of multiple of 9, so take 9 common. Common means divide by 9, so 9 3s are 27. So this bracket, that is 3m cube, complete this assume as cube and replace it by cube. On replacing it equation 1, that will give you 9 cube. So just see in the question, we have to bring 3 options, either 9 cube or 9 cube plus 1 or 9 cube plus 8. So from first we obtained 9 cube, now from second we are going to obtain 9 cube plus 1, and from third we are going to obtain 9 cube plus 8, like this. So we'll start from the second option. Second option is what? 3m plus 1. So we'll write here a is equal to 3m plus 1 on cubing both the sides. Now here students, here student used to do mistake on doing the cube. So first just understand the cube formula. Cube formula is a plus b whole cube is a cube plus b cube plus 3ab bracket a plus b. So what is a here? A is 3m. And what is b here? B is 1. So first is a cube. A cube means 3m cube, that is 27m cube. Then b cube is 1 cube. Then 3ab. 3ab means 3 into a into b. So a means 3m, b means 1. Then bracket a plus b. So 3m plus 1. Now in next step, 1 cube is 1, 3 3s are 9, 9 1s are 9. So 9m. Then this bracket as it is. Now when we'll open the bracket here, 9m will multiply by 3m. So that will give you 27m square, and 9m multiplied by 1 will give us 9m. Now this 1 I wrote at back. Now here, because we have to bring it in the form of 9 cube plus 1. So plus 1 you just keep alone. Now from remaining these 3 terms, take 9 common. Now taking 9 common means we are dividing by 9. So 9 3s are 27. Again 9 3s are 27. Then 9 1s are 9. one I not wrote, it's not necessary. Now what are the variables that you just write down as it is? M cube as it is, M square as it is, and M as it is. Now this complete bracket we are going to assume as Q. Now replace in next step by Q in equation second, just replace this bracket as Q, that will give you 9Q plus 1. So cube of any number is 9Q plus 1. Now the last option is 3M plus 2. So on cubing again we have to use the formula AQ plus BQ plus 3AB bracket A plus B. Put the values of A and B properly. Now here 3 3s are 9, 9 2s are 18. So what we got here 18M. Now 18M you have to open with the bracket. So 18M multiplied by 3M is 54M square. 18M multiplied by 2 is 36M. This 8 I wrote at back. Now this 8 you just separate it because in question we want it alone. Now from these three terms just take 9 common. Common means we have to divide by 9. So 9 3s are, 9 6s are, 9 4s are, and variables will come as it is. This complete bracket just assume as Q. Now since we assume this complete bracket as Q, so this complete bracket now again replace it by Q. So you will get 9Q plus 8. So from we had here, so what we found here, cube of any positive integer is either of the form 9Q or 9Q plus 1 or 9Q plus 8. So all three options we got from the three numbers. What are the three numbers? A is equal to 3M, then A is equal to 3M plus 1, then A is equal to 3M plus 2. Now why we selected B is equal to 3? Because we have to bring it in the form of multiples of 9 and 9 is divisible by 3. That's why we selected B equal to 3. Then we had wrote the Euclid division lemma, and then from all the possible values of R, we replaced R equal to 0, then 1, then 2. So from that we got three numbers, and by doing the cube of all that three numbers one by one we obtained 9Q, then 9Q plus 1 and 9Q plus 8. I hope this question is clear to you. If you have any problem, you can write in comments so that we can clear out your doubts. Thank you.